Alright, so let's just take a look at a limiting reactant problem here off of some of your practice, off of your practice sheet here. So we want to determine what the limiting reactant is, and right away what we notice is that we need to balance. We always want to start by balancing the equation. So in this case, I don't know, I'm going to just start here. I'm going to put 1 here. Looks like I have 1 iron, I have 3 chlorine. Oh, but I have 2 on the right side. So what do? I'm going to double what I know. So in this case, my 1 becomes a 2. I'm just going to get rid of that 1 just so we're not confused. That's a 2. And now I've got 2 irons, right? 2 irons. And I've got 2 irons, and I have 6 chlorines. So let's put a 3 in front of this. Gives me 3 calciums. Now I'm balanced. The reason why we want to do that is because we're going to come back to that later. We need those numbers in blue. So take each one of these problems one step at a time. Don't try to do everything all at once. You got 200 grams of iron 3 chloride. Well, I need to know, this is why we spent so much time writing formulas and naming, that this is my iron 3 chloride. And I'm starting off with 200 grams of that, and that's going to be my starting point. FeCl3. And I'm going to do a little bit of stoichiometry. Why? Because it's going to react, let's just write that down, with 120 grams of calcium. So I'm going to have 120 grams of calcium. And what else does it say here? So what is the maximum amount of calcium chloride that can be formed? Calcium chloride that can be formed, which is going to be that last compound. So to start, I want to figure out how much calcium chloride can I make if I have 200 grams of iron 3 chloride. And that should be, we should be able to do that by now. That's just a simple stoichiometry problem. So we've got 200 grams of iron 3 chloride. We know that we're going to have grams of FeCl3 on the bottom. And if I have 1 mole, I've got to go to the periodic table, and I've got to add up 3 chlorines and 1 iron. I'm going to get, it looks like 162.3 grams. All right. From there, now I use those blue numbers, right? Because I want to go from moles of FeCl3 to moles of, what am I trying to find? Mole of CaCl2. So that's where putting those boxes really helps, because I know what the problem gives me, and I know what I'm trying to find. So in this case, it's a 2 to 3 ratio. So my last step here, I don't want moles, I want, change that to grams. So 1 mole of CaCl2 looks like that weighs 111.1 grams. So when I punch that into my calculator, I get, boop, 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 multiply the top, divide by the bottom, looks like I get 199.98 grams. Alright, so what? That's CaCl2. That's how much product I can make. Alright, what about my other side here? What about the calcium? If I have 120 grams of calcium, how much of that same product can I make? Which one's going to run out first? And again, we've got to do another stoichiometry problem. So these are always going to involve 2 stoichiometry problems. 1 mole of Ca on top. This is where you're going to get really good at stoichiometry, because when you do these problems, it's the same thing over and over. I'm going to put this in blue again so you highlights. This time it's 3 moles of Ca, and remember where I'm getting that from. That's the coefficients. Oops. Do that. Moles. Gonna have my unit CaCl2. Alright. And we're gonna finish it, and it's the same numbers as the one above because CaCl2 hasn't changed. 1 mole of CaCl2 still weighs 111 grams. Punch that into our calculator. There's a little bit of space here. And that equals, multiply the top, divide by the bottom, 332 grams of CaCl2. So, we do all that work. We want to make sure that we answer the question, right? What does this mean? Well, it means that if I have 200, let me get my highlighter out here, if I have 200 grams of FeCl3, right, I can make 190, about 200 grams of CaCl2. If I have 120 grams of Ca, I can make 300 grams of CaCl2. So which one runs out? Well, the one that runs out is going to be the lower number of the two. So my limiting reactant, right, limiting reactant, that's going to be the lower number. Once I do this reaction, once this 200 grams gets used up right here, I'll use a different color right there, once that gets used up, the reaction stops. It comes to a halt. There's no more FeCl3. If we had an unlimited amount of FeCl3, well then my 120 grams of calcium right here, yeah, then maybe I could make 300, but I don't have an unlimited amount. Once this 200 gets used up, the reaction stops. So the most, make sure we always answer the question, the maximum amount of calcium chloride that can be formed is going to be 199.98 grams. What reactant is in excess? Well, that's going to be my calcium. My calcium is in excess. That's extra. There's some left over. Now, if you take more chemistry, we'll have you figure out how much is extra, but for right now, for the regular curriculum, we don't require you to calculate that. All right, so hopefully this video was helpful.